Hello, welcome to our second part of dimensional analysis. So right now what we're going to do is we're going to start working where we have two dimensions to start with, as opposed to the other video had only one dimension per problem. So we have 100 meters in 10.49 seconds. Now that was accomplished. Flojo, that was a woman's nickname. If you look it up, it was Florence Griffith Joyner, and she still holds the women's world record for the 100-meter dash, and it was in the 80s. So she was really fast. So we're going to convert. Now, what I like to do, and the way I do it, is I do time last, because one, I'm very good at converting time because I know the time conversions very easily. So that's my suggestion. I like to do time last. So I'm going to start with meters. I need to convert meters, and we're trying to convert it to miles per hour here. So I need to get meters to miles. And so if you look at your conversion chart, there are no meters to miles conversions. So we got a couple options here. So what I'm going to first do is I'm thinking I'm going to go from meters to feet, because I already have used that and I'm familiar with it. So remember, 1 meter equaled 3.3 feet. So I got 3.3 feet and 1 meter. And since this meter is on the top, I'm going to put the next meter on the bottom. So 1 meter under 3.3 feet. That's the conversion, like there. And then what I'm going to have to do is cancel out meters. And now I'm left with feet. And feet is not my final dimension. I need to get the dimensions to mph, again, miles per hour. So I got to get from feet to miles. And I always remember this from the movie, if you've seen it, Remember the Titans, when he's yelling at Petey to run a mile, and he hits him on the head with the football and says, run 5,280 feet. So that's just how I remember that conversion. But again, you have your sheet. So now again, that's 1 mile is equal to 5,280 feet. And since there, I need to cancel this feet, I'm going to put the next part of feet on the bottom. So 5,280 feet, and then that would equal 1 mile. That's the conversion. And now I can cancel out feet right there, and that then gives me my final conversion. Now I have miles as my dimension. Okay, and if you look at it, I also have seconds down here. So right now I am in miles per second. All right, and if you wanted to, you can go ahead and multiply this all the way out. You could multiply the numerators, multiply the denominators, and get a miles per second conversion, right? And you could get that number and then continue to convert from there. That's one option. I am going to take a different option, and I'm going to continue to change my conversions. And if seconds, now notice here, seconds is on the bottom. So if I want to cancel out seconds, I need to put seconds on top. And what I know about seconds, I know that there are 60 seconds in 1 minute. And now the seconds cancel out. And now I have miles per minute as my next conversion, my next dimension, sorry. All right. And then minutes, again, minutes is on the bottom. So what do I have to do to get rid of minutes? I need to put minutes on the top. And so now I know there are 60 minutes in 1 hour. All right, and minutes will cancel. And now, take a look, I now have hours on the bottom. And again, I have miles on top. And miles divided by hours is exactly miles per hour. So that's the conversion. All right, and now what I'm going to do is I'm going to take my calculator, and I'm just going to take and do the entire numerator. So I'm going to do 100 multiplied by 3.3, multiplied by 1, multiplied by 60, multiplied by 60. All right, if I type that in the calculator, I get 1188000. That's how many miles I have. And then I'm going to take the denominator, 10.49, 1, 5,280, 1, 1. I'm going to multiply that out, and I get 55,387.2, and now that's hours. All right, and then I need to divide those two numbers, and so if I take the 1,188,000 miles and divide it by 55,387.2 hours, I will get 21.2 448,999.05. All right, keep all the numbers round at the end, and now I would say, okay, well, let's say that's 21.45 miles per hour. So the world record holder in the women's 100-meter dash, Florence Griffith Joyner, or FloJo as her nickname was, she ran 21.45 miles per hour. All right, that's pretty fast. So this is a dimensional analysis when you have, again, there were 2 dimensions when I start, and I have, again, 2 dimensions in the end. So that's how you can convert 2 dimensions to another set of dimensions, but you got to convert each one individually in order to get there. All right, I'll have another example of this at the end, but I got some other fun things in between. Now, this next example is how many NFL offensive linemen are equivalent to 1 blue whale. Now, the fun part here would have been if we were in class, we would have been able to research the offensive linemen, and so I have to do that for you here, unfortunately, but if you were to Google NFL offensive lineman right here, the average offensive lineman is 312 pounds, is the average offensive lineman. And we'd have to figure out what does 1 blue whale weigh, and typically the blue whale is, they say, is 300,000 pounds. Okay, now the purpose is not to just simply get the easy answer. All right, the purpose is to show the dimensional analysis and consider what are we starting with. All right, remember the very first example, which was 3 meters into inches, right? 3 meters was what I was starting with. On this problem, think about what we are starting with. What is the number that we are starting with? What is the only number in the question? And the only number is the number 1. So then that is the number we begin with. We begin with the number 1, blue whale, and so that's where we start with, and we put that 1 blue whale over 1. All right. Again, if you like the way the science teachers do it, then you would put, kind of like a T, almost a T table. And so then 1 blue whale, well, 1 blue whale is equal to 300,000 pounds right there. So I would put blue whale, I got to put 1 blue whale down here. All right. And then that's 300,000 pounds, like that. All right, there's the conversion. 1 blue whale is 300,000 pounds, and I put the 1 blue on the bottom because I want to cancel out that dimension, and now I'm left with pounds. And what do I want to have in the end? I want to get back to offensive lineman is my final dimension. Well, 1 offensive lineman equals 312 pounds. Well, I need to put that next conversion here, and I have pounds that I need to get rid of, so I got to put 312 pounds down here so that pounds cancel out. And then that is equivalent to 1 offensive lineman. And now we can simply multiply straight across, so that's obviously going to be 300,000 on top. Lineman is the only label we have left. Divided by, multiply across 312. And I know that was an easy idea to come up with, 300,000 divided by 312, but it's not the answer that's challenging us here. It's the dimensional analysis that we're trying to do. So all of this work is the important piece. I know that this piece was, some of you might be thinking, that's the easiest thing I could have come up with. Why didn't I just do that? That's not the challenge. The challenge is to do the dimensional analysis here. And so if I divide 300,000 by 312, that's going to get me 961.5384615. Now, can I have a fraction of an offensive lineman? And the answer is obviously no. So I can't have 0.5 of a lineman. So how many do I have? All right, well, think about having to feed the number of people. If I only plan to feed 961, or should I plan to feed 962? All right, so people, I can't have half a person, right? And even if someone's missing an arm, they're still a full person. So it's either 961 or 962. the way I think about it, and the way that if you want to get the AP calculus, that exam will think about this is going to be 962 offensive linemen. Again, if you think about having to feed them, I have more than 961 available, all right? And it's not that I'm rounding up because that's a 5 or higher, all right? If I had 961.3, I still need to round up to 962 because this 0.3 is more than the 1 value, so I have to have more than 961 offensive linemen, so that means I have to have 962. And we will talk more about this rounding when we're in class and throughout the year. Okay, next example. How many seconds are you in school during a 5-day week? So right away, here's what we're starting with, 5 days. So I'm going to start with that number. 5 days is how I start, over 1. And I got to convert that to seconds. All right, so 5 days is what we have, and now I need to get to hours. Now let's think about this school day. How long are you in school? Now let's go with the typical normal school day, which means we start at 7:30 and we go until 2:20. Just about 7 hours. All right. Now let's say it's 6 hours and 50 minutes. All right. Now let's just assume that we're here a little bit before 7:30 and we're here a little bit after 2:20. All right. So let's just make it a little bit easier on us, and let's just say that during the week we have in one day. So I'm going to put days on the bottom. Hopefully you got that already. We're going to say we are in school for 7 hours, and now our days are gone. So we can cross off the value of days. And next we want to get from hours into seconds. Now we could go hours to minutes and then minutes to seconds. All right, and either way we're going to do this, we're going to put 1 hour on the bottom. The other way we could do this is we could really shorten this up. We know that in 1 hour there's 60 minutes, and then in 1 minute there is 60 seconds. So we can easily say, hey, there are 3,600 seconds, or 3,600 seconds in 1 hour. And we can cut that off a little shorter, and now hours are gone, and now I have my final seconds, except seconds. There we go. And now I can simply take that, and I'm going to multiply it straight across. So day 5, 7, 3,600 is 126,000 seconds in a school week. All right, our last example here talks about the famous horse secretariat who did the Kentucky Derby in 1973, and it took the horse only 1 minute and 59 seconds, and this record still stands. All right, so the one thing you got to know is the Kentucky Derby is 1 mile and a quarter, so 1.25 miles is how long it is, and if the horse was able to do that in 1 minute and 59 seconds. Now here's an issue right here. We have miles, minutes, and seconds. All right, well, to do this we can only have 2 dimensions max for dimensional analysis. So we either need to make this go to minutes and have a random decimal, or into seconds. So what I'm going to do is I'm going to turn this actually into seconds, because then I don't have so much decimals, and I can just simply use 119 seconds, and that's an easier number to deal with than what 1 minute and 59 second is 1.9 blah 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 blah. So there I have 1.25 miles in 119 seconds, and I want to turn that into kilometers per hour. Okay, so I'm going to go ahead and try it here, and if I look at my conversion chart, I can see that in 1 kilometer there is 0.621371192 miles. And so then do I put that as 1 kilometer over the miles, or do I put the miles over the kilometer? And realizing that miles is there in the numerator, I then must put miles in the denominator. So then I'll put kilometers in the numerator. So there's our 0.621371192 miles. And I can now cross off miles, and now I have kilometers per second. And so I have kilometers covered, so I can stop there. And then now I need to get from seconds to hours, and since seconds here is in the denominator, I'm going to have to put seconds in the numerator, and so I have 60 seconds in 1 minute. Or if you wanted to, you could go ahead, you could do that and then do 60 minutes in 1 hour, or I could simply do in 1 hour, I could have 3,600 seconds in 1 hour, and just have less conversions then, and seconds cross off, and there I have hours for kilometers per hour. And then what I do is I simply multiply across, so I multiply the numerator, 1.25 multiplied by 3,600, and that's going to be 4,500 kilometers. And if I multiply 119 by this decimal and by 1, I will have 73.94317,185 hours. Now, you might be tempted to round that number right there, but if you round right now, that is going to lead to rounding errors, and you only want to round one time per problem, and when you round, it is the very last thing you do. So now what I'm going to do is I'm going to take this fraction and I'm going to divide this out. 4,500 divided by the 73 number, and that will be 60.85754624. And it is possible to have a fraction of a kilometer and a fraction of an hour. So I can have a fraction of a kilometer per hour. So I can say, let's say it's 60.86 kilometers per hour. That's how fast the horse Secretariat ran. Now, this week I will be making sure to cover and talk to you about dimensional analysis whatever day you happen to be in the building. So even those of you that I'll see on Friday, we will still talk about dimensional analysis to make sure if you're having any issues, we will hammer this down. This dimensional analysis lesson is extremely important to start the year with because we will refer back to this lesson throughout the year. So now you should be able to finish up the back side of the dimensional analysis worksheet, or even the front side if you didn't finish it completely. That concludes our lesson. Good luck, have a great day, and hope to see you soon.